I've come to Cork in Ireland to the Pipe Life Renewables Academy, and Mike Geary here, he's the technical training manager, and he's going to take me around and show me what they've got. So in no particular order, I can see you've got heat pumps over here. You don't make heat pumps, do you?
No, we don't make heat pumps. What we do is we design heating systems with underfloor heating, any distribution model, radiators, etc. But obviously the heat source will be the heat pump, which is two types we do. We partner up with Hitachi for the split system.
Okay.
We do a monoblock system. We partner up with Medea. The ultimate difference between the split and the monoblock is, I guess, half of your heat pump is outside, so it's collecting the heat from the air, and the heat distribution is carried out within the dwelling.
And all these you're looking at are air to water, are they?
Correct.
This is not really taken off in the UK in the same way as it has in Ireland. Now, why do you think that is?
I think there's a couple of reasons, really. I suppose ultimately the benefits here in Ireland is it's government driven. The government are really behind reducing the carbon greenhouse gases by 55% from what they were in the 90s up to 2030. As well as that, I think the generation that are building houses now, in terms of the homeowners, more conscious of reducing their greenhouse gases, their carbon footprint. They want to leave the world, I guess, in a better place than what they found it. Technology as well, I think technology is after really taking over in terms of you can control your heating systems from anywhere in the world, you can check different temperatures in different rooms, etc. Then for the retrofit market, there's huge incentives with better energy homes, community home schemes, so you can gain anything up to €100,000 in grants through the SEAI. Now that's obviously not just covering heat pumps, it's covering the entire fabric of the building, windows, insulation, floors, underfloor heating, heat pumps. So there's a myriad of grants available for the retrofit market. So it's really, the Irish market has really embraced the technology, and again, from the government perspective, there's huge incentives there to get away from the old fossil fuel. Technically, it's very challenging to build a new house now with a fossil fuel option. So that's why it's
now
it's
you've
really
got an awful lot of rural properties in Ireland.
Correct.
Obviously, they were running on oil and solid fuel and so on.
Correct.
So they would be the prime candidates for moving over to heat pumps.
Absolutely, yeah.
Now, I know you're a plumber, not an electrician. I see an issue here because they've got overhead power supplies to many of these rural properties.
Correct.
Is there an issue there with trying to get enough power to the property to run an all-electric heating system or not?
There is challenges there with the current grid in terms of investment from the infrastructure. However, there's a big move over to PV panels as well.
Oh, okay.
So a lot of these rural houses are contributing to the demand of the house, and as well as that, they can actually sell it back to the grid.
Yeah.
So that's overcoming the shortages really that are on the current grid at the moment.
Yeah, and of course electric cars as well coming in. So there's another little thing,
Absolutely.
demand on the system, isn't it?
Absolutely.
So this is Hitachi's heat pump. What do you bring to the party? What are your products here that you're manufacturing, that you're... So, I mean, you're not doing this for the love of, bringing installers in here, showing them all this. You want them to use your products somewhere.
Yeah, pretty much. So primarily we manufacture pipe. The area that I'm responsible for is the renewable side. We design systems effectively. It's coupled together very well in terms of underfloor heating, which would be an ideal heat distribution for low temperature applications such as the heat pumps. We sell it under the Flowplast brand in the UK. We sell it under the Pipe Life brand here. So we do full design, bespoke design in terms of underfloor heating. And obviously we manufacture the pipe, which has a 50-year guarantee, which is above and beyond any competition that's out there. Within the training centre, we see an awful lot of shortages in the sector, particularly the skill set that's going into renewables at the moment. It's very low numbers. There's a big drive to bring kids back to offer apprenticeships. There was a big move to academic third level education, but now there's huge incentives to get guys in.
We've had quite an association with an organisation or company, Heat Geeks in the UK. They are trying to address this lack of skills and training people up. But this heat pump isn't really the issue. The issue is how you get the heat from there into the underfloor heating system. And this is really basically the design of low temperature heating systems, isn't it?
When we design a heating system, we have a couple of markers that we have to achieve. One of them is we have to heat the house to a comfort level. Okay, so we have to reach certain temperatures in different rooms so that the homeowners are very, very comfortable. That's easy, but we want to do it. We want to achieve this with the lowest amount of input, so the most economical way possible. So that's where the challenges come in. And obviously we need to meet the demands of the hot water in the house. So we're very, very conscious here when we design a heating system that it's designed in such a way that the house can be heated at a very, very low temperature and therefore being most economically friendly as possible and reduce the cost of running the house.
Lower bills, yeah.
Yeah.
So we go from heat pumps to your next bay, which is radiators and underfloor heating. This is all on the same system, isn't it? Are you saying that we can supply this with a heat pump?
Absolutely. So underfloor heating is the best application to run with a heat pump. You have a big floor area to heat, therefore you can run your heat pump at a much lower temperature. The next best, I guess, then is low temperature radiators. They're aluminium radiators. There's a very, very fast recovery time, so they heat up quite fast. The downside to that, they cool down quite fast as well. As well as that, to take out the myths that are out there, you absolutely can use steel radiators with a low temperature application as long as it's sized correctly, and that's
so
the key.
Just a larger radiator.
Exactly. The perception is out there that you can just fit a heat pump into your existing heating system, but I would strongly advise get an expert in to assess the house first, because your current radiators are probably too small.
Yeah. So
current radiators are designed to run at 80 degrees temperature. We're trying to achieve a comfort setting in the house at a much, much lower temperature.
So what would you be typically flow temperatures?
Flow temperatures between 35 and 40 ideally. We use weather compensation, so the colder the weather is outside, the harder the heat pump works to meet the demands of the house. And then finally we have the towel warmers, primarily fitted in a bathroom. Once again it's sized correctly, there will be no issue.
I look down here at the manifold for the underfloor heating. There's no pump, there's no mixing valve on there. So basically what you're saying is you're feeding this with 40 degrees, say, into here. There's no need for you to cool it down. It can go through the floor at that temperature.
Absolutely.
No problem, and back, and that maintains the flow rates.
The intelligence of the heat pump can modulate the temperature up and down depending on the outside air temperature. There's built-in circulating pumps in the heat pumps that we use, and depending on the size of the house, we may have to put in secondary pumps or buffer tanks, etc.
If an installer is looking at a particular job, say a house, can they come to you for a system design? Is that how it works?
Absolutely, yes. If it's an existing house, we can carry out a technical assessment within the house, discuss with the homeowner the best application for them in terms of level of control, heat distribution, whether it's radiators, underfloor heating, and if it's new build, we generally work off the drawings. All the new builds are built to minimum building regulations, probably a little bit higher than the current building regulations.
So you know what the heat losses on those houses are?
Very, very easy calculated.
Away,
and then we can decide then with the homeowner or the developer that what type of heat pump to put in, what type of distribution again, and level of control.
And in new build, that's primarily going to be underfloor?
But yes, pretty much, yeah. 90% of it will be underfloor.
So you've got weather compensation on here. You've got it outside temperature.
Exactly.
So that's not that there, that's the internal one.
So that's the internal temperature setting. So we generally would offer a time and temperature control in each room. The majority of cases you're only really heating half your house. So you're only heating the rooms that you're in. And then we have the app control that you can control it through your phone or your iPad or whatever. When we're designing a heating system, the most efficient way to run the heating system is on weather compensation again. So when the temperature outside is lower during the winter months, the heat pump works a little bit harder. But as the temperature increases outside, this time of year, the heat pump only works very, very in the background.
Where would you mount the sensor for the weather compensation on the building, not in the south facing?
So the weather compensation sensor is built into the outdoor unit. We generally keep it not in south facing.
So these are Pipe Life products here.
This is the Pipe Life press fit system. We call it under the Press brand. The pipe here is manufactured here in our factory as well. We partner up with an underfloor heating manifold company, and we also partner up with a UK company for the controls, which is Heatmiser.
We'll be talking about 16 mil for this, will be for the underfloor heating?
Yeah, primarily it's 16 mil. So we designed an underfloor heating pipe, Qualpix Easy Lay, and the benefit of the Qualpix Easy Lay is when you roll it out, it stays straight.
I know, yeah.
You're not fighting with the pipe to try and twist and get it in. And it is a multi-layer pipe. It has an EVOH barrier as opposed to the aluminium barrier.
Yeah. So that's the oxygen diffusion barrier. Yeah?
Exactly,
Whatever,
absolutely.
Yeah, whichever way. I've got to say, I do like to see a bit of copper surface run, but actually this looks every bit as neat, doesn't it? I mean, some people might even prefer this to having copper pipe. You know, when people say you can't run plastic pipe on the surface, with this you definitely can, can't you?
Absolutely, yeah. It comes in coils and straight lengths.
I was going to say, so that would be a rigid length, yeah?
Exactly, correct, yeah. They come in 4 metre lengths, so
yeah.
So
It looks very tidy,
good.
doesn't it? Very good.
We have 3 different pods here. The reason being is that we have installer training on a regular basis.
Okay.
So a part of the installer training, we will put these units into alarm, we'll put them into a fault, and the part of it then is they team up and they will find the fault, repair the fitting.
And the fault would be what? On the flow rates
It
on
could
here,
be,
rather than, it's not in the unit itself?
Not really in the unit,
No.
because of the fact that we don't expect the installer to go into it, but it would be a system fault. It could be a pressure reducing valve, it could be a drop in pressure, it could be a flow rate issue. So on this side we have a different type of heat pump, which is the monoblock heat pump. The fundamental difference between the monoblock heat pumps and the split heat pump is all the heat is collected outside. The heat transfer is done outside within the unit. So effectively what's happening here is that there's 2 primary pipes going into your heating system.
Yeah.
Originally, I guess it was designed for the retrofit market, that you could just cut off your oil or gas boiler, bolt this to the side of your house and connect in. And in theory, it sounds great, but in practice, it needs a bit more investigation from a professional installer to assess the possibilities of an install of a heat pump. It's not a situation that it's one trick fits all.
So what I'm looking at here is, looks like you're coming out on a bit of galvanised iron actually, and then into copper, and then into your pipe.
The Qualpex reduces the level of vibration that can go into a house, so that can be a bit of a nuisance as well. A part of our design would be specifying what pipe to connect onto as well.
Yeah, because a lot of them use that flexi stainless steel.
And you can very much do that, but aesthetically it's not the prettiest.
No.
But again, the Qualpex pipe will reduce the vibration going into the house.
So you'd be looking to insulate that
Absolutely.
pipe work.
All pipe externally will be insulated.
What happens if it freezes up?
Well, we would specify that there's glycol put in the system. In freezing conditions, when the temperature goes below a certain temperature, there is backup electric heaters that will keep the water from freezing. However, if there's a power cut with low temperature freeze, there is glycol. We would recommend glycol down to about -12 degrees.
And that's got no issues with your pipe glycol?
Absolutely none. No issue whatsoever.
Because there are people out there, I mean, HeatGeek being one of them, who said that you shouldn't use plastic pipe on heat pump systems. They are advising against it, and I've never fully understood why they say that, because it seems to me like a bit of scaremongering. So that's the heat pump, but I can't help noticing this young fella here, Erling Haaland, is up here. Now, he's not cheap. What's the connection between him and the heat pump?
Absolutely. So Medea sponsor Man City.
Oh, is that what it is?
So that's exactly it.
I didn't know that at all. This looks good, doesn't it? In the tan pipe. We never see this in the UK. This is an Irish fashion, really, isn't it?
Yes, indeed. It's the typical brand. The minute they see the tan pipe, that they know it's the Qualpex brand.
It's yours. It's nice looking. I've got to say, I'm warming to it a lot. You know, when I first saw it on the production lines coming out, I don't know, but actually there with the brass, it looks brilliant. Game-changing heating solutions. What's the game changer?
Absolutely. Well, look, I think there's a couple of things really. This particular product has a 10-year warranty, which is an incredible commitment to the brand. Very, very high level of technology in terms of control and running costs. You can connect onto a BMS, or you can connect onto your phone to see exactly how much energy you're using. You can predict your running cost. You have a live view, you have a historical view, so it's very, very interactive and very, very informative. They're super quiet. It's a very specific design on the fan to reduce any turbulence in the air, so it's a super, super quiet. A big issue with the heat pumps is can be noise, can be vibration in the house. It gets rid of all these issues in terms of noise or vibration. Super efficient. They're the most efficient unit on the market.
Are they?
Yeah, absolutely.
Oh, wow.
Yeah, and using the R32 refrigerant gas.
So are these distributed through the merchant network?
Yeah, we sell through the merchant, so we'll take over the full design, so there is correspondence between ourselves and the installer, or ourselves and the homeowner, and it's all distributed through the merchant.
So when I was saying about system design earlier, it's not a service where a plumber can come to you and say, I need a heat pump design, you do it for them, and then they go off and use a competitor. How does it work?
So basically what it does, we receive a set of drawings, and we will do up a bill of quantities for all the parts for the install. We will only do the design once we have received a PO or a commitment that they are going ahead with it. So it's only then we'll do the design, full bespoke design as per the house. But again, there is a little bit of correspondence with the end user and the installer to see best case system for their house.
Ah, yeah, that's nice, isn't it?
Yeah, so one of the challenges in the industry at the moment is that, as we discussed earlier, is the lack of skill set. So what we're trying to do to help that is to prefabricate as much as possible. Yeah. We have a pre-plumbed cylinder so that an awful lot of the work is done for the installer already. So it's kind of our prefabricated or pre-plumbed domestic hot water cylinder. So what you have here is you have obviously your domestic hot water cylinder for the demands of the house, for hot water for showers, etc.
Yep.
You have your zone valve here for your, we'll say, downstairs or whatever application it is, and you have a zone valve here for upstairs. But the benefit of this is we can design it to whatever demands that the installer has.
You can configure it
We can bespoke it whatever way he wants it.
So that fella there, what's...
just running through the flow, so you have your heat pump outside, the flow from the heat pump goes into your diverting valve here.
Guessing this has got a big coil in it if it's for a heat pump.
Exactly, yeah, so it's a rapid recovery, very, very large coil.
And this is specifically made for a heat pump, isn't it?
Designed for a heat pump.
Or low temperature.
Yeah, so it's designed for a low temperature application. The difference between this and a traditional domestic hot water tank, it has a much bigger coil within the tank for heat distribution.
Got it. Stainless steel?
Stainless steel, yeah, stainless steel coil, stainless steel internal tank.
So the heat pump's coming in here?
Yep, exactly.
Yeah.
So you have 28 mil coming in here into the diverting valve. The heat pump makes the decision whether it needs hot water demand or space heating. So the heat pump will turn this valve accordingly, heat the domestic hot water, and then divert back over to space heating when necessary.
Automatic flow regulator.
Correct.
Pressure operated flow regulator.
Yep. This would be a perfect fit for a 3-bed semi. You have a ground floor zone, you have an upstairs zone, and you have a domestic hot water zone. Yeah. So it covers all areas for the heat demands.
Nice drain off. I like the drain off. It's just so much easier.
Yeah, and I think the benefit to this as well is the cold feed is coming in from the top and the hot out is coming in from the top. So you're not coming all the way down to a cold feed on the bottom. Yeah. There's an internal pipe that is fed down within 3 inches of the bottom. It's all about assisting the installer in terms of speed.
You're still going to have external expansion vessels on here.
Correct.
There's no internal baffle there.
No.
Obviously. Do you know off the top of your head what the capacity that is?
This is a 200 litre cylinder. So we do 2 and we do 300 litre cylinder, and for the larger applications we do a 500 litre cylinder as well.
So is that a recent addition to your range?
So a very, very recent addition. Listening to our customers and trying to satisfy their demands and the challenges that they come across, this is a perfect fit for them in terms of speed on the installation.
So moving on, your little display, I spot a bit of Flowplast rainwater here.
Absolutely, yeah. So we're trading this under Flowplast in the UK. So from the roof line and the downpipes and the drains.
Oh, because you do the fascias as well.
Absolutely,
now, don't you?
Yeah.
All that.
All manufactured.
So this is this yours?
Absolutely, yeah. So I guess with the current building regulations, etc., the houses are so airtight. We have to control ventilation in the house. So this is an option here. We do a full heat recovery system. This is an MEV, so it's a mechanical extract ventilation system. Yeah. So effectively, it's managing the airflow in the house to avoid any condensation, any dampness issues.
We're big on that. We get a lot of correspondence on that. So up here, in the roof space, you've got a manifold. So these are the outlets then, yeah?
They're the outlets. So there's trickle vents in the windows. So the air is being pulled in at a very, very low speed and it's dumped outside.
Oh, okay.
So it's just managing the airflow because the houses get really, really stuffy.
There is the positive input ventilation systems in the loft that put the house under pressure.
Correct.
But I understand there's a bit of a problem there in timber frame houses because you don't want to be pushing moisture out through the walls. Yeah, timber frame house.
There is some challenges, and it's not a one system fits all. But this particular option is trickle vents in the windows, pulling very, very low speed air in and dumping out just to keep the air quality within the house at a high level. So now we're just moving on to where we offer the training for the installers in terms of underfloor heating.
Oh, okay. This is training week. I've done a few of these in the past. Yeah.
So we get guys out, get them used to the different pipes that are out there, how to install. We also offer it to the local training colleges in the area. Some of the apprentices, I suppose, may not have had any experience with underfloor heating. So those guys come out for a day and lay out the pipe as if it's in the building site environment. We have two types of pipes. We have the aluminium barrier pipe that has recently entered into the market in terms of underfloor heating, and we have our own easy lay pipe as well. So we let them play around with the two pipes and see what they prefer.
So that stays where you put it, just bend it round.
Yeah, so that's a more rigid pipe.
Yeah.
There's for and against that. We have installers that prefer to use that particular application. Pipelife manufacture both pipes, but this is manufactured here in Ireland, in our factory here, and the multi-layer pipe, the aluminium multi-layer pipe, is manufactured by our sister company in Hungary.
So this is 16 mil.
Yep, absolutely.
Is this marked up per metre? In other words, you know how much you've got left on the roll?
Exactly. So we do 500 metre coils, we do 100s, 150s and 500 metre coils, but it's marked every metre. So when the installer is rolling out as per the drawings, he will roll out the adequate amount of pipe as per the drawing and then connect it back up to the manifold.
When he starts, that's say 500.
Correct.
And then it's counting all the way down.
Counting all
to
the way
zero.
down.
Okay,
yep. Yeah. Exactly. So it's very, very informative and very easy to install.
I don't want to pick holes in your display here, and I understand why you've done it, but I spot a deliberate mistake here.
Lack of tape?
Lack of tape, but it would also be lack of polythene to protect the silver foil.
Oh, yeah.
On the insulation. But I know for a training week you wouldn't need it, but just
exactly.
You do see guys putting it down without that protective layer.
You do.
And then the building inspector comes around to take it all up again.
Yeah.
Put that down. I've even seen people put the polythene over the top of.
Putting the polythene over the top is a no-no.
Yeah,
because what you need with underfloor heating, you need the amount of wrap it around, get the concrete in around maximum surface contact.
Conduction, isn't it?
Exactly.
Yeah.
Maximum surface contact with it. When you have the polythene over the pipes, you have this shape of a U, and it's not, the concrete isn't getting in under the pipe. So that would be a no-no. It
would kill probably 30% of the heat.
Absolutely, yeah, absolutely. So again, it'd be challenging to meet the demands of the house then from a comfort point of view. And you've only one chance. It's a very, very expensive fix, and that's why we would recommend go to a highly recommended or established company when you're looking for your heating design, because it's a very, very expensive fix if you don't get it right. Again, our pipes offer a 50-year guarantee. You know, there's nobody else out there offering that level of guarantee. No. It offers a level of comfort to the homeowner. They're going to be living in the house for the rest of their lives. They don't want to be digging up the house in 20 or 30 years' time.
So why is it always 16 mil in underfloor? Is that because of the manifolds? With
16mm pipe, generally you can run 85 to 100 metres of pipe without getting into the technical level of head loss on the circulation, and there's friction that builds up on the pipe. So 16mm, it's a low form of pipe, so you have plenty screed over it, and at the right distances it'll give you a perfect even distribution and no extra strain on pumps, valves, etc.
Yeah. The other thing is that I know this expands when you're warming up. Obviously the less you heat it up, so if it's 40 degrees it's not going to expand as much as like when it's going through at 80 degrees. But where does the expansion go? Once you've covered this in concrete, is that pipe trying to expand inside the concrete? What's going on?
It's trying to expand, but because it's buried within the concrete's going to keep it together. Now the concrete will expand and contract very, very marginally, but the builder will have expansion joints at certain areas when they pour the concrete, or they can cut expansion joints after, but expansion contraction, it will happen. Outside the perimeter of the room as well, it would be recommended to put a little 25mm insulation to allow that expansion and contraction.
What about when you're moving from one room to another, when you're running through across a threshold?
A protective layer over the pipe, we call it ducting. The different rooms will be expanding at different times, so you might discover a hairline crack, but this will never be seen by the end user, because if it's tiles or timber floors, it'll never show up in the finished floor, because with the tiles, all the adhesive out there now is flexible adhesive. The majority of timber floors and tiles now are designed for underfloor heating applications, because it's so common in the industry.
And it's just a question of limiting the temperature on the floor, which is, it's interesting, because if you get something like, say, vinyl tile, luxury vinyl tile, it says 29 Celsius is the top temperature, but obviously it's coming through at 40. But there's a difference here between the water temperature and the surface temperature of the floor.
Absolutely.
So that's where you would need that sensor.
Yeah, and that's one of the reasons that we have a flow temperature of 40. That will give a maximum temperature of 26 degrees on concrete.
Oh, really?
So there's a specific heat capacity calculation that's done, and that's why we try and limit the underfloor heating to 40. When you heat concrete up above 29 degrees, there is potential of degradation and there's potential of cracking. So that's the pitch point of where we want to be at.
And I use flow screed in my jobs because it's just a lot easier and a lot nicer.
Well, the flow screed is an excellent application with underfloor heating because, again, it really gets around the pipe, all those little nitty-gritty places, and the response time is much, much quicker than it would be in a traditional sand and cement concrete mix.
Down screed. So thanks for showing us around, Mike.
Sure.
I really enjoyed it, and I learned a few things. I didn't realise you did all these different brands. So if you want to find out more about any of this, then follow the link in the description below to the Skill Builder website because you can get all the information from there.